Hello everyone and welcome back. Today it was the last video that talking about chapter 16 fire protection system. In the last video we talked about the first type of fire extinguishing system and it was the portable system. Today we will talk about the second type, fixed fire extinguishing system. In an aircraft, it's important that the type of fire extinguishing system be appropriate for the class of fire that is likely to occur. For example, on the cargo compartment, we can't use a portable system, so we will use a fixed system. There are two basic categories of the fixed fire extinguishing system, and they are conventional systems and the second type, high rate of discharge system. These two systems are the types of fixed fire extinguishing system, and we will talk about each one individually. As general rule, the type of system installed can be identified by the type of extinguishing agent used. How that's come? For example, in the conventional system we will use carbon dioxide, but in the high rate discharge we will use the halogenated hydrocarbons. We will start to talk about the first type, the conventional systems. Conventional fire extinguisher system consists of a cylinder that stores carbon dioxide under pressure and remotely controlled valve assembly that distributes the extinguishing agent. The normal gas storage pressure range from 700 to 1000 psi. Carbon dioxide cylinders are equipped internally with one of three types of siphon tubes. What are the siphon tubes? Here, when we see here, we will find that we have a short type siphon and this straight siphon. How we can identify that this type of cylinder use siphon straight or short flexible siphon? We will read here, if a CO2 carbon dioxide cylinder is mounted vertically in the vertical way, the straight siphon tube is used. Also, you can find that if we use a straight siphon tube, you can see a label or stamp on the cylinder and it's written by S. If you found S, that means that this bottle use a straight siphon tube. What about the second type? However, if the cylinder is mounted horizontally, a short flexible siphon tube must be used. Like this. If the bottle lied horizontally, we will find that the type of siphon used is the short flexible siphon. Also, you can identify that by the stamp or label you find it on the bottle. It's written by SF. That means short, flexible. So that means this bottle use a short, flexible siphon. The cylinders used in aircraft typically utilize either a straight rigid or short flexible siphon, and we talked about that. The type of siphon tube installed in the cylinder is determined by the cylinder mounting position, and we talked about that. After we understand the internal construction, we will talk about the external construction of the conventional fire extinguisher system. Here we have a fire extinguisher operating valve that it will receive the signal from the cockpit. After that we have a main distribution line, and we have the cable conduit, and the last thing we have the assembly of the cylinder on the structure of the aircraft. To operate a conventional fire extinguisher system used to protect an engine compartment, a selector valve in the cockpit must be manually set for the engine that is on fire. Some carbon dioxide systems designed to protect engine fire zones have multiple bottles, which gives the system the capability of delivering extinguishing agent twice to any of the engine compartments. Each tank of carbon dioxide bottles is equipped with red thermal discharge indicator disc and yellow system discharge indicator test. As we see here on the structure of an airplane, we have two indicators. The two colored indicator discs are visible on the exterior of an aircraft equipped with carbon dioxide or high rate discharge system. If the red disc is missing, it indicates that the fire bottles have discharged because the bottle pressure exceeded limits due to thermal heating. What about the yellow indicator? If the yellow disc is missing, it indicates that the bottle will discharge through activation of the system from the cockpit controls. This way, during a pre-flight inspection, the flight crew can identify the condition of the system. The second type of the fixed fire extinguishing system is the high rate discharge system. The high rate of discharge is the term applied to the fire extinguishing systems found in most modern turbine engine aircraft. The typical high rate discharge consists of a container to hold the extinguishing agent, at least one component assembly, and a series of high pressure feed lines. As we see here, this the container of the high rate discharge, and here the component assembly. Each container is partially filled with an extinguishing agent such as halon 1301 and sealed with a fringable disc. Once sealed, the container is pressurized with dry nitrogen. As safety feature, each extinguishing container is equipped with thermal fuse that melts and releases the extinguishing agent if the bottle is subjected to high temperature. As we see here, this is our fringeable disc, and this the fusible safety plug. Now, when we have an electrical signal that come, it will push the cartridge and it will break the frigible disk. When the frigible disk broken, the halogenated hydrocarbon will discharge and will go to the system for extinguish the fire. But if the temperature rises and the pressure increases inside the bottle, the fusible safety plug will melt and will release the pressure from this area to prevent explosive of the container. After we understand the two types of fixed fire extinguisher system, now we will talk about the inspection and servicing. Regular maintenance of fire extinguishing system includes inspecting and servicing the fire extinguisher bottles, removing and reinstalling the discharge cartridge, testing the discharge tubing for leaks and testing electrical wiring for continuity. Container pressure check. A pressure check of fire extinguisher containers is made periodically to determine that the pressure is between the minimum and maximum limits prescribed by the manufacturer. The only way to determine if the appropriate amount of extinguishing agent is in a given container is to weight the container. Discharge cartridge. The discharge cartridge used with high rate discharge containers are life limited, and the surface life is calculated from the manufacturer's date stamped on the cartridge. The manufacturer's surface life is usually expressed in terms of hours and is valid as long as the cartridge has not exceeded a predetermined temperature limit. Many cartridges are variable with a surface life up to 5,000 hours. To determine cartridge surface life, it's necessary to remove the electrical leads and discharge the hose from the bonnet assembly. Once this is done, the bonnet assembly can be removed from the extinguisher container so the date stamped on the cartridge can be seen. Therefore, care must be taken in assembling or replacing cartridge and bonnet assembly before installing on an aircraft. If a discharge cartridge is removed from a bonnet assembly, it should not be used in another bonnet assembly. In addition, since discharge cartridges are fired electrically, they should be properly grounded or shorted to prevent accidental firing. When assembling a discharge cartridge into bonnet assembly, this cartridge and this the bonnet assembly, it's best to use an exploded view drawing like one above this one. Once assembled, the entire bonnet assembly is attached to the container means of swivel nut that tightens the against a backing ring gasket.